Welcome to the next video in our course. In the previous video, we learned that the life cycle of a research study begins with an idea that is formulated into a research question. In this video, we will go into detail on how this research question is established. Research starts with an idea. An idea can come from anywhere, but in research, it usually develops from one of the following: an observation or pattern. Observation. Right heart catheterization is the gold standard for diagnosing pulmonary hypertension, but is there a less invasive procedure that has similar diagnostic effectiveness? Pattern. A primary care physician notices that many of his hypertensive patients also tend to have elevated creatinine levels, a sign of worsening kidney function. Is there a link between these two conditions? Here, a researcher might note a pattern or common occurrence that she sees in practice and might wonder if there's something deeper going on. Gaps in existing literature. Mistrust in the healthcare system is a well-known predictor of poor health outcomes, but no one has studied levels of mistrust among Black individuals, who tend to have disproportionately poorer health outcomes. Do Black individuals have higher levels of distrust in the healthcare system compared to their non-Black peers? It has been established that cell phone reminder apps significantly improve medication adherence, but how effective are they among people who are not tech-savvy? In these two cases, a relationship has already been established, but there are still pieces missing. Specifically, the relationship hasn't been studied in subpopulations where the established association might be different. Extensions, modifications, or improvement of current practices. Can in-person social worker visits be replaced with telephone discussions for individuals with transportation issues? A researcher hopes to replace a standard multivitamin tablet with a gummy. Here, there are established practices that could be improved by making them easier or more convenient. A research question should never be generated from and tested on the same data set. In other words, you should not search data that have already been collected in order to develop a research question, then use those same data to answer the question. A common but extremely inappropriate use of data is to search for patterns and correlations and use those findings to both formulate and then test the research question. For example, suppose a researcher has a sample of 300 clinical measurements and survey responses from the National Health and Nutrition Examination Survey, or NHANES. The researcher performs exploratory analyses on these data and creates a scatter plot of systolic blood pressure and eGFR, a continuous measure of kidney function. A scatter plot is a visual way to show the relationship between two measurements and can help identify patterns and trends. In the plot, we can see that lower SBP values tend to correspond to higher eGFR values, and higher SBP values tend to correspond to lower eGFR values. The researcher can also plot a curve to estimate the relationship between the two variables, and in this curve, we see a clear linear trend between SBP and eGFR. A scatter plot can be generated for different pairs of measurements and combined to form a matrix plot. By creating this plot, a researcher can quickly identify patterns between multiple measurements. We have seen the linear trend between SBP and eGFR, suggesting that higher SBP is associated with worsening kidney function. We can also see what looks like a trend between SBP and another measure of kidney function, urine albumin to creatinine ratio, or ACR. Higher values of ACR indicate worsening kidney function, so the positive trend we see in the plot is more evidence that systolic blood pressure is associated with worsening kidney function. Finally, we might notice what looks like an interesting trend between PHQ sum, a measure of depression where higher scores indicate more severe depression, and hemoglobin A1C, a marker for diabetes, where the higher the A1C, the greater the risk of developing type 2 diabetes. More severe depression seems associated with higher A1C levels. It is completely reasonable to use exploratory analyses like these to formulate your research questions. For example, is higher SBP associated with worsening kidney function? Is depression associated with A1C and diabetes risk? However, once we have formulated the research questions based on these data, we can no longer use these same data to answer those research questions. We must collect new data to analyze. You may wonder why. It may not be clear where the issue lies, so let's consider a simple example. Suppose a researcher flips a quarter 10 times, resulting in 8 heads and 2 tails. This might lead her to hypothesize that the coin is unfair and favors heads. Using the same results, the 8 heads and the 2 tails, to confirm the research question is an example of circular reasoning, which is a logical fallacy that occurs when the conclusion of an argument is used as a premise of the same argument. In other words, in exploratory analysis, we find that the quarter is unfair in 10 flips. We then formulate the research question, the quarter appears to be unfair. We should not then use the 10 flips to confirm that the quarter is unfair. This would be inappropriately testing the question on the same data because the conclusion is the same as the premise. In other words, the researcher has no additional evidence to support the research question after the question was formulated. The correct thing to do would be to flip the coin 10 more times and draw a conclusion of the fairness of the quarter based on this new set of flips, or this new evidence. Going back to the NHANES data, the same argument applies. It would be inappropriate for the researcher to use the scatter plots to formulate research questions and then regression models to test the question in the same data. Even though the analyses are different, the evidence is the same and has the same circular reasoning. Thus, after formulating the research question, the researcher must find new data, perhaps a different year of NHANES data, or a different data source entirely. Or she may use these exploratory analyses to motivate a grant proposal for new funding to collect new data to test the research question. Once the research question is formulated, the next steps in planning a research study and finding a data source are critically important. This is an excellent time to form a collaboration with a biostatistician or other quantitative scientist who has the expertise to help design a study and find a data source that can answer the research question. We will emphasize this in a future video where we discuss the basics of study design. In general, once a potential data source is identified, feasibility checks can be performed to determine if the data are appropriate. For example, you may want to check that the sample size is large enough and that the cohort characteristics match the population you wish to target for inference. If these requirements are not met, you may need to find a different data source. However, it is not okay to perform any statistical test and discard the data source if results do not look promising. This is cherry picking and is a source of research misconduct discussed in the previous video. Once the research question is formulated, the data source should be chosen with great care. In summary, research starts with an idea. This idea can come from many places: observations in clinical practice, gaps in existing literature, or modifications to current practices. In these cases, a researcher will formulate a research question based on the idea, then collect data in order to answer the research question. Occasionally, a research question may come from existing data. However, that same data cannot be used to answer the research question. The researcher must find new data source or collect new data. Finally, we have given the general process of formulating the research question, but defining and refining a good research question is a much more complicated process that takes careful thought and planning. The finer criteria and PCOTS framework for formulating a research question and designing a study are two valuable resources that can help. Links to materials on these resources are available. In the next video, we will discuss converting the research question into a testable hypothesis and introduce the concept of hypothesis testing.